I'm going to take a quick look here of linking Tekla model down to Steel Project's PLM software and ultimately down to the Ficep CNC machines. Here we have a typical Tekla model: bolts, copes, welds, plates, angles, beams, typical kind of variation of pieces and connections. What we'll do is simply add another piece to the model. So we'll draw a beam from midpoint perpendicular, then set it so it's at mid to mid. Then we'll pick up the relevant connection, in this case it's a clip angle, and we will connect the pieces together like so. And there is the final piece we've added to the model. It's just a quick spin around that. So again, just a typical kind of model. Okay, the next step then is we want to link that down to the Steel Project's PLM software. There is a application we can download from the warehouse or from Steel Projects Direct, which exports the data out. This creates an XML file. For us in Tekla it's quite simple, it's just a one-click production. So we click on the model, say OK to that, and it produces the data directly to go to the Steel Projects PLM software. Once we open the Steel Projects PLM software, we can then import the file we've just created. There it is. Okay, so we'll say OK to that. It then reads in the data created from Tekla, passes all the information to the Steel Projects PLM. It creates a project. If we take a look at that project, you can see there's the one there. If we just expand that, everything's in phase 1, and then beneath that we have got all the assembly numbers. So if we just walk through the assemblies, you can see we're not just passing through simple CNC data, but the whole three-dimensional object is passed through from Tekla to Steel Projects. And if we walk through there, you can see the results. That's a good example. So if we zoom into this one here, you can see there we've got stiffeners, bracing plate. Not only does it pass through that information, but also the markup information, the mark of the pieces, what's fitted together, all the complete CNC and production information. As well as having the assembly information, we do have information on every single piece as well. So we'll just walk through a few more of those. So now if we go to the parts, and we'll just select the whole project, and then these now are individual parts and components of that model. Again, if you click on there, you can see a column and a beam stub. If you zoom in, you can see the layout information, the marks of the piece that's connected, so that's the plate that's connected to the beam, and the scribing or layout of how that piece is fit together. So the machine then will actually mark and show the actual fabricator how those pieces go together without any manual layout whatsoever. So simple enough process, just a few more examples and a few little walkthroughs. Okay, then what we do is we pick up that project and we take that project then into our virtual workshop. Now within Steel Projects PLM, what we do is we describe the machines we have, the layout of the machines, the layout of the factory, and the capabilities of the machine, what they can handle, what size of pieces they can handle up to, what's the minimum they can handle as well. It then takes the Tekla pieces, looks at the virtual workshop, and tells you the most optimized way to pass that piece through your factory, along with precise timings on how long it's going to take to actually fabricate or make that piece in the workshop through the machine. So if I click on this one here, you can see then that goes to the, if we could just zoom down, you can see that goes to the Gemini cutting machine, and that's the time it's going to take for drilling and for outline marking, just for that one piece. And again, if we click through the pieces, you can see the timing and the route through the workshop that piece has to take. So again, some example beams, plates, all going to different machines. So it sorts the pieces and tells you the best machine and the capability of the machine it's going to go to. Okay, what we do next then is that's the pieces. We then say, okay, let's take that to the plate nest, to the bar nesting. Sorry, this is the linear beam nesting. You tell it what the actual lengths of members are available. It then uses those lengths and nests the pieces from Tekla into there with minimum wastage and most optimum nesting. So if we run this through, it then looks at all the options and gives us the best option. So there you can see just a 2D view looking on those pieces, which are now being nested into one bar. If we zoom in, you can see that the red piece is the waste. You can zoom in there, you can see that's the thickness of the saw blade for cutting. But again, you can see all the mark and layout, so that's exactly what that machine is going to make from that piece. And again, all the elements are nested, again with minimum wastage, optimum usage of the sections. It's not just for beams, of course, it handles any profile, such as in this case angles. And again, just a few other examples what we can take a look at. Simple, easy. If we zoom in, that's the final one, again with the fit up, nesting, all the information for the machine. Okay, what's left over from that? Oh, before that, of course, we'll create some reports. Let's just create a bar nesting report. This is our order list, what we can send to the stockist or supplier to tell them what material we need for that project. Okay, what's left next, of course, is the plate elements. So we'll send those to the plate nesting software. It just processes those through into format that it can actually read. Just takes a few seconds to do that. And then again, what we do is we tell it what size plates are available to nest into. Again, let's just process those plates. And there we are. So then you can see that's the plates there ready to be nested. Just take a quick walk through those. It separates them into thicknesses and grades as well, so you don't have to worry about that. You then tell it what size plates you have available to nest into. So here's all the different sizes I've actually got available to me. We'll say OK to that, and then we say OK, automatically nest those through. It picks up the plates and again does the optimum nesting for that size plate, thickness onto and correct grade onto the plate. There you can see then the plates nested onto various sizes. What we can do then is a quick simulation of how the machine is going to operate. So in effect, this is looking in plan on the machine. It's going to go through there, drill the holes. I've got that going slowly first of all. This is just a simulation of how the machine will work on that plate. So you can see it's going to drill the holes first of all, and then it's going to go through and plasma cut those plates. And that is what the machine will do in a virtual world. Okay, so once that information is complete, what we do is we then send it down to our workshop. So here's our workshop with the machines, and then of course what we've told it now is exactly how that project runs through that factory. Okay, with all the information for cutting, coping, drilling, routing through the workshop, and we get a full and precise timing on how long it's going to take me to that project or to run that project through the workshop. We can of course have multiple projects running at the same time. We can run those through steel projects exactly the same way. So again, you can see then all the routing of this particular project, drilling, timings, is all done directly from the Tekla model. Just an example of an automated workshop. If you have one or two machines, the process is exactly the same. Okay, so the machines themselves, let's take a look a little bit more in depth on the machines. So of course you have machines then for drilling, stamping, this is what we call the layout marking. So the information of how those pieces fit together is driven directly from the Tekla model, so the machine knows how to actually scribe those pieces and show the fit up. Again, all the drilling information, layout, simple enough so you can see exactly how that fits together. Again, some simple drilling instructions. And for sides, it's drilling on all three sides obviously here, so all the information. Okay, let's take a look at another machine. Again, this one you can see it's already sawn the end there. What it's going to do again is it's going to drill the holes, it's going to do the layout marking first of all. So again, where the pieces fit up on that particular beam, it's going to do the layout marking so you can see exactly. So the fitter just quite simply puts the plate against the line marking, no need to measure, it's all done directly from the Tekla model. Again, the instructions for drilling, tool changes, different size holes. when it's doing the timings from Tekla as well into Steel Projects PLM, it knows it's quicker to drill a smaller hole than a larger hole, so it takes all that into consideration as well. There we are. And again, scribing can even be on the underside, so the layout marking can be on all sides. So it's real true three-dimensional information. As well as that, we have the three-dimensional coping. So you can see here the robot is cutting or coping these pieces as per the Tekla model again. All the instructions for slot holes, rat holes, notches on the side, all this information passed directly from Tekla. So any cuts or copes you put in Tekla are linked directly to this plasma cutting machine. And an example of the kind of finish or information that can be passed through. Okay, so we've taken a look at linear elements to the machines, and again the final one now is of course the plates. So with the plate nesting, the information is passed directly down to the machine, in this case the Ficep Gemini. Just an example of how the machine looks. You can see the nested parts onto the plates there, but again the information of that nesting is passed through to the machine. Again, this can also do the layout marking, information on cutting, even including three-dimensional preparations can be done using this machine as well. Again, all passed through from the Tekla model. If the piece has a bevel, that information is passed through to the Tekla plate cutting machine. To the Ficep plate cutting machine. An example of the weld preparation. Okay, so that information is running through the factory. So the machines are cutting, they're making the pieces. As it goes to each machine, the information can be passed back to the Tekla model to show the status of every piece within the factory. So for example, here what I've got is I've got setup information for CNC product, progress, welding, coping, painting, all the different processes that are going on in the factory. So as it goes through each station in the workshop, you can see then it color codes the model to show exactly what has gone through the factory on what date, on what time. It will report that visually back to the Tekla model. So you can see there green is fully complete and delivered to site. A very brief overview of Tekla to Steel Projects and Ficep CNC machines.